So for question 1, we've got our goodness of fit test to do. We're looking at a binomial 4 and 0.5. We're going to have to find out some expected ones first. So let's write that down. We're going to go x is a binomial 4 and 0.5. And we want to know the probability that x is equal to 1. So the probability that x is equal to 1, we'll grab our calculator here. I might as well do it in our distribution menu here. A binomial, we want it to equal 1 from 4 trials with a 0.5. And that tells us we've got 0.25 there. So 0.25 for that one. The probability that x is equal to 2, that's the next one after. Let's just change that to a 2. And that one's 0.375. And the probability that x is equal to 3, that's back to 0.25 again, isn't it? Because it's a binomial and it's symmetrical there. Now they're the probabilities, but to find out the expected numbers, we need to times each of these by 100. Why times by 100? Well, because they do it 100 times. And so the expected number for this one here is 25. Here we've got 37.5, and here we've got 25 again there. Now, that gives us our little table. Our table here being the observed and the expected numbers. The observed numbers were 10, 33, 33, 15 and 9, and our expected numbers are 6.25 at either end, 25 here and here, and 37.5 in the middle. So these are the observed values and these are the expected values. So part A done, 3 marks for that. That's nice, isn't it? Now, the hypothesis test. So we'll start with a null hypothesis. The null hypothesis is that binomial 4 0.5 is a suitable model. Usually a mark for this. And H1 is that binomial 4 0.5 is not a suitable model. You notice those expected values there, all of those are decent numbers, they're all above 5. So our degrees of freedom here is just going to be 1, 2, 3, 4, 5. 5 take away 1, which equals 4. Probably got another mark for that. That tells me what my critical value is going to be. Let's use this from the calculator, shall we? So critical value. So we're going to go to distributions, chi-squared test, the inverse chi-squared test. And what percentage test are we doing? It says in the question it's a 5% test. And I've got 4 degrees of freedom, which tells me that my critical value is going to be 9.48. Don't stop there. 7. Don't stop there. 7. We've had a little bit of issues there, making sure we do want a little bit more there. So 9.477 or 9.488. Don't round it any more than that. Let's go back to the table here. I need to put the values in. So list 1, I'm putting in 10 and 33 and 33 and 15 and 9. They're my observed values. Here I'm putting the 6.25, the 25, 37.5, 25 and 6.25 there. And we're going to do a test. We're going to do a chi-squared test, a goodness of fit test. The observed are in list 1, the expected are in list 2. We can save the contributions into list 3 if we like. Off we go. So we can go there straight away that we've actually got our chi-squared value. Our chi-squared value is 10.56. Let's just get that out of the way then. So 10.56 is bigger than our critical value of 9.4877. So it's too far out. We'd really like that total to be 0, to be spot on. We'll allow it up to 9, but 10.56 is too big. So we will reject H0. And so we will then say evidence suggests it's not a suitable model. Binomial 4 0.5 is not a suitable model. And as we've done it really quickly, look, it's only 4 minutes and it's a 9-mark question. What we do is we can bring back the calculator And because we saved all our contributions down here, see those there, we put them into list 3, we could write those things down as well, couldn't we? So these are our observed, you could write them down just underneath the table here. So I've got 2.25, I've got 2.56, that is 0.54, 4, and what's the bottom one there, 1.21. So this is your observed minus expected squared divided by expected, and I could write those down just as a making sure I've shown all the lines that they could possibly want. But there we go, we're still only 5.5 minutes into a 9-mark question, a usual binomial